So next type of power you're going to talk about is solar power. And here it's also, you have to be very careful with the vocabulary, right? Because we normally think of solar panels as the panels that create electricity. And IB is very particular about the words you use. So here we're going to separate normal solar panels with photovoltaic cells. Okay? And normal solar panels we'll be using for the creation of heat. So there are panels that capture sunlight and heat up water. While photovoltaic cells we will use to refer to the actual solar panels that we think of when we think of the energy production using sunlight. Right? So here, first of all, this is a diagram of the solar panel. Of course, this is very simple. All you need to create a solar panel is something that is dark, that will absorb light, and connect the pipes to the water source, right? These pipes will heat the water will flow through it back to the water tank, and you use this to heat up water, which is, water heating is one of the biggest uses of energy inside the house, right? We all take hot showers at home, but it takes a lot of energy to heat up the water. And we all know that if you use electricity to heat up the water, well, you can, 100% of the electricity is transformed to heat, right? But when you do that, you lost a lot of energy producing the heat, that electricity in the first place, right? So converting electricity to heat is maybe not the best way to use it, because a lot of energy was lost in the production of the electricity in the first place. You're better off using other sources of energy to create heat and heat up water. The downside to this is it's not very reliable in its power output, right? If it gets cloudy, you could get no water, hot water. So what you do is you have other heaters as well, right? Probably using a combustible fuel like natural gas, which again would use 100% of the, well, close to 100% of the heat, energy, and transfer to the water, which is better than using electricity because you lose less energy, right? Next, we have the photovoltaic cells, which look like this. You're probably more familiar with images like this, right? Everybody probably has already seen solar cells in use. It captures solar sunlight, right? Initially, back in the 90s, the efficiency of the solar cells was around 2%. So if you got 800 watts of power from sunlight, you can only get 16 watts from a panel that's 1 meter squared. Eventually, they got better. A normal commercially available solar panel that costs around $100 to $200 per square meter, produces 200 watts of power and has 20% efficiency, which is very easy to see nowadays. High efficiency solar panels can go up to 60, and they are very expensive, and they're usually only for satellites or specialized cases where you do not have a lot of area, but it is the only source of power available, right? Of course, again, you have to talk about the advantages and disadvantages of each, right? So if we talk about the advantages of solar panels, first, it produces no greenhouse gases during its use. Second is renewable, right? And Being renewable, it's free. So solar energy is free, right? Nobody has to pay for sunlight, mostly. So let's talk about disadvantages. Now, what can be a disadvantage of solar panels? Right? And let's change this to pros. And the disadvantage of solar panels is, of course, the main disadvantage is it's only available during daytime. During daytime, there's seasonal variations. Which means that during the winter you get less energy, right? If you would like to see why this is, let's open up some space. And what happens is, as you go to higher latitudes, higher angles, right? The angle is not the same. So here and here, the amount of power is the same, but because it's spread across a bigger area, the intensity is lower, so you get less power per meter squared. That's the first thing. Second thing is, because it goes through more atmosphere, it scatters more, and therefore it's also less intense, right? There's also the issue that is affected by weather, right? If it rains, there's a lot of clouds, you probably don't have a lot of solar energy. Affected by weather, affected by weather. Among the other things is the cost. I quoted a cost about several $100 to $200 per square meter, right? That means that per watt, it's very expensive. So there's a high initial cost. Right? And finally, it requires a large area. If you want to make 1 megawatt, right, you need at least 2,000 square meters, which is quite a lot. And 1 megawatt is a very small power plant. You usually have to have power plants in the order of 50 to 100 megawatts to be efficient.